Okay, so get this. We might be able to, like, manipulate black holes.
Whoa!
Those, like, ultra-dense enigmas of the universe
Yeah.
using just the power of, quantum mechanics and information theory.
Really?
That's what black holes, quantum information energy and propulsion hints at.
Okay.
And today we're taking a deep dive into those very excerpts.
Cool.
We're talking about potentially accessing like near infinite energy,
Wow.
creating mind-boggling propulsion systems, and even warping time itself.
It's a truly revolutionary idea. And you know what's remarkable is that it's grounded in real science.
So for you listening, get ready for a wild ride as we unpack concepts like the Penrose process,
Yeah.
Hawking radiation, and quantum superposition.
Yeah.
These aren't just abstract theories. They could hold the key to unlocking a whole new understanding of physics.
Yeah, the source material starts by proposing that black holes are the most efficient and powerful systems we know of.
Okay.
All due to their incredible information density.
Yeah.
Essentially, the more tightly information is packed and the less randomness or entropy exists, the more powerful the system becomes.
So black holes, these massive cosmic vacuum cleaners sucking up everything in sight,
Yeah.
are actually the ultimate information repositories.
Exactly.
Yeah.
They represent the extreme limit of information compression,
Okay.
where matter, energy, and information are squeezed into singularities.
Okay, that's mind-bending.
Yeah.
But how do we tap into that power?
Yeah.
The source material mentions something called the Penrose process,
Right.
which supposedly allows us to extract energy from a rotating black hole.
That's right. The Penrose process describes how we might be able to steal some of a black hole's rotational energy by exploiting a region just outside its event horizon called the ergosphere.
Okay.
Imagine a spinning carousel.
Right.
If you jump off at the right moment, you gain extra speed.
Yeah.
The Penrose process is similar, using the black hole spin to fling matter outwards with increased energy.
So it's like siphoning off a tiny bit of the black hole spin and turning it into usable energy.
Precisely, this concept establishes black holes as the most energy-dense systems we know of.
Okay.
But there's another fascinating phenomenon, Hawking radiation.
Right. I've heard about that.
Yeah.
It's the idea that black holes actually leak energy over time,
Yeah.
almost as if they're evaporating.
Right.
But if they're losing energy, couldn't we theoretically collect it?
Yeah.
Like imagine plugging into a black hole for power.
That's exactly what this research explores.
Oh.
And it becomes even more intriguing when we introduce quantum mechanics into the equation.
Quantum mechanics now. Things are about to get really weird, right?
Absolutely. The source material talks about sending a particle that's in a quantum superposition into a black hole.
Yeah.
Think of it like Schrodinger's cat,
Right.
where the cat is both alive and dead at the same time until we observe it.
So we're talking about a particle experiencing multiple states simultaneously inside a black hole.
Yeah.
How is that even possible?
It's a consequence of the bizarre rules of quantum mechanics. But what's really fascinating is the idea of engineering the collapse of those states to send information back before the particle even crosses the event horizon.
Wait a minute. Are we talking about sending information back in time, like creating a causal loop?
That's one of the mind-bending implications that physicists are considering, and it doesn't stop there.
Wow.
We could potentially use a black hole's intense gravity, which warps time as a sort of time anchor, because time slows down near a black hole.
Yeah.
Could we exploit that time dilation to manipulate energy across different time frames?
Okay, I need a moment to process all of this.
Yeah.
We're talking about potentially extracting energy from black holes, sending information back in time, and even manipulating time itself.
Yeah.
It's like something straight out of a science fiction movie.
It does sound incredibly futuristic, but these ideas are rooted in solid scientific principles, and this is just the tip of the iceberg.
You know, one thing that's always puzzled me about black holes is this idea of information loss. I used to think that anything that fell into a black hole was just gone forever.
Right.
Information included like the ultimate cosmic shredder.
That was the prevailing theory for a long time. The idea that black holes were these cosmic sinks where information disappeared, but then came Hawking radiation,
Right.
which challenged that assumption.
Right, because if black holes are emitting radiation, that radiation must be carrying some kind of information, right?
Exactly. It suggests that information isn't destroyed, but possibly scrambled and re-emitted.
Okay.
Think of it like a library where all the books are thrown into a blender.
Okay.
The information might still be there,
Yeah.
but it's completely disorganized and difficult to decipher.
So instead of being destroyed, the information just gets scrambled beyond recognition.
Yeah.
Does that mean we could potentially unscramble it?
Ah,
Like put the pieces back together?
that's where things get really interesting.
Okay.
Some physicists believe that Hawking radiation is a form of quantum tunneling.
A phenomenon where particles can pass through seemingly impenetrable barriers.
Mhm.
In this case, the barrier is the black hole's event horizon,
Right.
the point of no return.
So information could be escaping the black hole's grasp through these quantum tunnels.
That's the theory.
Wow.
And that's where the idea of information structuring comes into play.
Okay.
What if we could manipulate this tunneling process by sending in a particle
Yeah.
that's been pre-structured
Uh-huh.
with a specific information pattern?
Okay.
Could we influence the information that gets radiated back out?
I'm picturing it like encoding a message onto a particle and beaming it into a black hole.
Yeah.
Would we then get a structured response back in the form of Hawking radiation?
You're getting the idea. It's like using the black hole as a kind of quantum information processor. And this is where the concept of entanglement becomes incredibly powerful.
Entanglement, you mean that spooky action at a distance that Einstein famously disliked?
Imagine taking a pair of entangled particles.
Particles that are linked in a way that even when separated by vast distances,
Yeah.
they still influence each other.
Wow.
We send one particle into the black hole
Okay.
and keep its twin here on Earth.
Right.
Now, even though one particle is trapped beyond the event horizon,
Yeah.
they're still connected.
So by manipulating the particle here on Earth, we could potentially influence the information coming out of the black hole through its entangled partner. It's like having a back channel to communicate with something trapped inside a black hole.
It's a mind-blowing possibility, and while still highly theoretical, the implications are profound.
Wow.
If we can control information flow in and out of black holes,
Yeah.
we might unlock entirely new ways to manipulate energy, gravity, and even time.
Let's talk about those practical applications.
Yeah.
The source material mentions something called energy harvesting from quantum systems.
Yeah.
What does that even mean?
Imagine this: if structured information can influence energy extraction from black holes, perhaps we could create artificial micro black holes or utilize existing dense objects
Okay.
as incredibly powerful energy sources. Think of it like tapping into an almost infinite energy reserve.
Is this where the concept of zero-point energy comes in?
Uh-huh.
The idea of extracting energy from the vacuum of space itself?
Exactly. Zero-point energy has been a theoretical concept for decades.
Right.
But harnessing it has proven immensely difficult. Black holes, with their immense information density, might be the key to finally unlocking that potential.
Okay, so near infinite energy. What about propulsion?
Right.
Remember, the source material also talked about something called information-based propulsion.
Yeah.
How would that even work?
Think about it this way. If we can control the structure of information in a black hole's Hawking radiation, we could create an imbalance in the energy flow,
Okay.
a kind of directed energy beam.
Right.
Instead of needing fuel, we'd manipulate information itself to generate thrust.
So we're talking about something like a black hole-powered engine?
Yeah.
A way to travel through space using the energy of a black hole.
It's a fascinating concept.
Yeah.
And while it sounds like science fiction,
Right.
the underlying principles are based on our understanding of quantum mechanics and general relativity.
It's like we're taking the wildest ideas from science fiction and discovering that they might actually be possible. But wait, there's more, right?
Yeah.
We haven't even touched on time manipulation yet.
Yes. Time manipulation, perhaps the most mind-boggling concept of them all. Remember how we talked about black holes warping time
Yes.
due to their intense gravity?
Right, like a cosmic time warp
Uh-huh.
where time slows down near the black hole. But how could we manipulate that?
If we can manipulate information within a black hole,
Yeah.
it's conceivable that we could also influence the flow of time itself.
Hmm.
Imagine using a black hole's time distortion to optimize energy usage,
Okay.
speed up or slow down processes,
Uh-huh.
or even control the rate at which information updates in a system.
Hold on, are we talking about actually controlling the flow of time?
Yeah.
Like slowing down time to make a process more efficient?
That's the idea, and it's a concept that could revolutionize everything from computing to energy production to space travel.
Yeah.
We're essentially talking about rewriting the rules of reality as we know it.
This is all so incredible, but it also seems unbelievably complex. How would we even begin to test these ideas?
That's the challenge, isn't it? It will require pushing the boundaries of our current technology and understanding we need to develop new experimental techniques, build more powerful quantum computers, and refine our theoretical models of black holes.
It sounds like we're at the beginning of a scientific revolution, a
Yeah.
new era, where information itself becomes the ultimate tool for understanding and manipulating the universe.
I believe we are, and the possibilities are truly limitless.
You know, it's almost like overwhelming to think about like the implications of everything we've discussed.
Yeah.
Black holes, quantum mechanics, information as like the fabric of reality.
Right.
It's mind-boggling.
It is.
But what strikes me is that these aren't just abstract theories anymore. The source material suggests we're like closer than ever to actually putting these ideas into practice.
That's what's so exciting. The pieces of the puzzle are starting to come together.
Yeah.
We're not just waiting for some distant future breakthrough.
Yeah.
We're on the cusp of a new era of scientific discovery.
So what does that future look like? What are some of the potential real-world applications of these concepts?
Imagine a world powered by, like, near infinite energy, extracted from engineered micro black holes.
Okay.
Picture spaceships propelled not by conventional fuel,
Yeah.
but by manipulating information itself within the extreme gravitational fields of black holes.
And let's not forget about time manipulation.
Oh, yeah.
The possibility of controlling time itself to optimize processes or even influence the rate at which information updates in a system.
Right.
It all sounds so incredible, but is it even achievable?
It's certainly a monumental challenge, but the potential rewards are immense. Think about it. We could revolutionize energy production, transportation, communication, even our understanding of the universe itself.
It's almost like we're talking about becoming architects of reality.
Yeah.
Shaping the very fabric of existence.
Yeah.
But with such immense power comes immense responsibility, right?
Absolutely. Any technology this powerful has the potential for misuse.
Right.
That's why open and honest discussions about the ethical implications are crucial. We need to ensure that these technologies are developed and utilized responsibly for the benefit of all humankind and the preservation of our planet.
So as we stand on the threshold of this new scientific frontier, what are the next steps? What are the big questions that still need to be answered?
The source material ends with a profound question. Where do we push next?
Okay.
Do we focus on energy extraction, time manipulation, information-based propulsion?
Wow.
These are the grand challenges that await us.
It's a question that should spark the imagination of scientists and engineers for generations to come. And for our listeners out there, I think it's a question worth pondering as well.
Definitely.
Where do you think we should push next?
As we wrap up this deep dive into black holes and information engineering, I encourage everyone listening to keep exploring, keep questioning, and never stop being amazed by the mysteries of the universe. We are living in an extraordinary time, a time of unprecedented scientific discovery, and the future holds possibilities beyond our wildest dreams.